Today we are going to start talking about car setup, but not exactly the way that most people do. Now, today we talk about a bit of theory and the basics. What's really happening? What are we trying to achieve? And first, I have to address something, and this is maybe where Thibaut and me can have a discussion because he brought it up in one of these meetings. My argument is that in RC there is this myth that somehow RC cars are different, they work differently to real cars, or even that different brand cars somehow function differently. I don't know exactly how, but somehow the laws of physics just don't apply the same to all cars. So this is something that I've heard over the years many times, and I disagree. I think that all cars, RC, full scale, you name it, whatever brand, they all share the basic fundamental principles of how tires work, how a race car geometry functions. All of these basic principles are the same. You can uh, you can study and learn to understand what's happening. The difference is that the requirements are different. What we want or need from the cars differ. Also, the tuning window. If you compare, for example, 8-scale buggies, you may think that, okay, this is strange. I do the same change on car A and car B, and the effect is different. Well, that's because maybe the tuning window is so different. In fact, the function and the theory behind what you're changing is the same. It's just that you perceive it differently on the track. So that's something that I think needs to be said first, because if that wasn't true, then everything that I'm about to say wouldn't apply to all cars, but in fact it does. I remember Jared brought this up, that there was something that he disagreed with me about. Is he here? Is
I am here.
Mr. Thibaut is here? Okay, good. So
I'm here.
did it apply to something here, or do we talk about it then later?
I think we're talking about something a little different. I'm I'm more so saying I don't feel like all exact physics really work the way that you might think in racing, with our RC cars or any racing for that matter. I think, um,
Do you have an example?
just kind of like physics theory. Well, I'll use the example of where the center diff is in an RC car. Uh, you know, Engineers that I've talked to say that based off of physics, the length of the drive shaft shouldn't matter where, like where that center diff is in the car, the length to the front, to the rear, it shouldn't really matter. The power should be the same. And, me not knowing any physics, not being an engineer, I know just from the different cars that I've driven that that is untrue based on the feeling that I have, because when the center diff is farther in the center, you can run a slipper or a much heavier diff oil than when the diff is in the back of the car, because that power delivery feels completely different.
Okay.
That's just my example there in RC. And I think when you're racing and you're pushing things to the max, you know, general physics, I think, can get really pushed. Yeah, the general idea might be similar, but I think that you can, you know, things pushed to like a extreme level can just be a little bit different. I'm not sure how to word that
Well, I mean,
correctly.
I don't know what exactly the discussion was. Maybe if it was about the drive shafts themselves, that the length of them doesn't matter, that could still be true even though you perceive a difference on track, because the difference you notice may be because of something else, like the weight distribution or something like that. So it doesn't, you can both be right. If they were just saying that the length of the shafts doesn't matter, it's irrelevant, that's fine. That could be correct. And you could also be correct that there's a difference that you feel on track. Do you see what I mean?
Yeah, I see what you mean,
So this is kind of
but
this.
I'm gonna disagree on that. But
Okay, well, this is kind of it's a very specific point, this example, but this is what I mean. That drivers feel something on the track, maybe feel something with the same change, feel something different on two different cars, and then conclude that these cars are different, like fundamentally different somehow. But that's not the case. They aren't. The fundamental principles are the same. They function the same. You perceive them differently for some reason. And sometimes we don't really understand what that is. The reason is that race cars are really complex systems that are dynamic. Everything is changing all the time. The car is driving around the track, suspension is moving, load is transferring to off some tires onto other tires. Tires are deforming. The driver is driving and controlling the car. Different drivers drive in different ways. They have different sized inputs. Timing of steering and throttle is different. There are so many variables that it's very difficult to pinpoint exactly effects of a change, for example. So it's if you want to argue about something very specifically, like this is happening because of this thing, I agree that's very difficult. But that's not really what I want to do here today. Today, what I want to do is present to you the sort of my basic understanding of how these cars work and what we are doing when we are making adjustments. And I've sort of spent the last few years trying to simplify and break down all the fragmented information into sort of understandable chunks. And we'll see how well how good of a job I've done after this, if most of you understand what I'm explaining. So anyway, we can continue that conversation with Thibaut after this. But let's get into it. So what's the goal of setup? We always talk about car setup. So what are we actually trying to achieve? In my opinion, what we are trying to do is we are trying to get the car to be comfortable and predictable and fast. So we adjust the setup for the track conditions and for the driver skill level and preference. I think that describes well what we are trying to do. We have to start breaking this down from tires, because the tires are what connect the car to the track. This is the only part of the car that's connected to the track surface. This is what gives us traction. So I think it makes sense to focus our thinking around what's happening at the tire. If we look at a tire, it's on the track. if we put more load on it, we push it harder into the track surface, it will provide more traction. The reason for that is that the contact patch of the tire, the part of the tire that's on the track, will be bigger as the tire is pressed into the surface. Also, the way rubber works, you push the rubber tire into the track surface, friction is going to be higher. So you want to have load on the tire to get the most possible grip. Now, our cars are four-wheel drive, so we have 4 tires, not just one. To get the best possible grip out of a four-wheel drive car, we would like all 4 tires to be loaded to the maximum load that the specification of tire we have can bear. That would give us the best possible grip. Now, the problem is that we are driving around a track, and if you've ever been in a car, you'll know that as soon as you start moving, you feel that your body starts moving inside the car also. So you accelerate, you feel your body being pushed back. That's the feeling you get. You go around a corner, you feel like you are going to fall out towards the outside of the corner. Brake, you move forward. So that's an indication that the same thing is happening at the tires. You can't have a situation where all 4 tires are equally loaded to the right amount in a moving car, because we're always accelerating or turning or braking. So load is transferring. And there's a graph I need to show you, because this is like the first really important point that I need you to think about and understand. So here we have a graph, and on the horizontal x-axis here, it's load, so vertical load on a tire. And y-axis here is cornering force. You can think of this as grip in a corner. So let's imagine that this is the left and right tire of the rear end of a car. And the car is, let's say, for simplicity's sake, it's turning left. You can even imagine that you're looking at this. It's like a graphical representation of the tires. You are driving into the computer screen, turning left. So the outer wheel would be here, inner wheel here. Okay. Now this point here, AA, is in the case that these tires were loaded to this amount, the rear axle would have this much grip. So AA, both tires are loaded to this amount. That's the grip it would have. If in reality, when you're driving around a corner, the outside tire will have more grip, and the outside tire will be heavier loaded, and the inside tire will be less loaded, so more lightly. How can I say? More lightly loaded. Now, when you average that out, this point BC is the amount of grip on the rear axle in this case. So you can see that there's a difference here. When both tires are equally loaded, there's more available grip. When outside tire is more heavily loaded, inside lightly loaded, there's less available grip. But notice that the rear axle, the total amount of load on it is still the same. Right? We aren't changing the amount of load on the entire rear axle. We are just changing the distribution of load between the tires. The reason that when tires are more unequally loaded, that the maximum available traction is less, is that as you increase load on a tire, the grip does increase, but it's not linear. At some point, as you increase vertical load on the tire, it can't produce as much more grip. So it's not a straight line, it's a curve like this. This means that at some point, adding more load won't help you create more grip anymore. So this is important to remember, because when we are adjusting our car, we can think about the distribution of load on left versus right tire in a corner. So how much load are we transferring? If we transfer more load, we have less grip available in the corner. If left and right tires are more equally loaded, we will have more grip available in that corner. This will become more clear as we go on, but I needed to show this to you first. So one thing that we need to make really clear is another myth in RC. We already saw these pictures before. We see a car here accelerating, the rear is squatting. Here, nose is diving. Here you see a car going around the corner. The car is rolling towards the outside. The fact that the chassis can move, that the chassis can roll and dive and squat, that's an indication that load is being transferred, but it's not the load transfer itself. Suspension movement doesn't cause load transfer. This is something that people often misinterpret. Go-kart that doesn't have any suspension has load transfer. You can't stop load transfer by stopping the chassis from moving. Load transfer is a separate thing from suspension. The only way to reduce the amount of load transfer is actually either lowering the center of gravity or making the car wider or longer. Those things will help to limit load transfer, but the suspension doesn't do that. This is something that I often hear said, but it's not how it works. What the suspension movement actually does is it delays load transfer. Now, this is the second really important concept to remember. When we are adjusting our car, when we are changing the setup, what we need to keep in mind is that what we are doing is changing the time it takes for the car to roll or pitch, the alignments of the tires to change. Whatever changes the car is going through, when we adjust it, we are adjusting the time it takes for those things to happen. So time is the key word. If we have a car with very stiff suspension or no suspension at all, load transfers off some tires onto other tires very quickly, almost instantly. When we have suspension, if we make the suspension soft and we allow the car to roll a lot, pitch a lot, we are delaying that load transfer. So the load transfer will happen more slowly. So now we need to introduce a new concept. And the reason is that when we talk about grip.
One of the things I was thinking about, and then I'm not sure if this is what you meant by load transfer. Like if you've got a really technical track, you're talking thinner oils, load transfer from right to left, front to back. And I would think more left to right. If you have like a bunch of 180s and stuff like that, are you talking load transfer in another way?
By load transfer, I mean how the tires are loaded. So we should always think about the tires and how they are affected by the car, what's happening to the car. Because the tire touching the ground, that's what provides us grip. So when you load a tire more, it provides more grip. So we are interested in knowing which tires are loaded more, because those tires will have more grip at that point in time, right? So when we go on, these things will become more clear, but it's just each step of the way. I hope you understand the point, and then as we go on, it will all come together in the end, hopefully. So
Okay.
anyway, we have to introduce a new concept, because often when drivers talk about cars and what they are feeling on a track, there can be situations where one driver says that even if they drive the same car, try the same car at the track, one driver can feel that they have good grip, and another driver driving the same car can feel that the car is loose. And how can that be? Like, how can two drivers drive the same car and have the opposite feeling? One driver saying that the car has good grip, the other driver saying that it's loose. And this has to do with initial versus overall grip. So on one page, it explains initial versus overall grip. Can you see this image? So when we talk about initial grip, remember I said if it's a go-kart, there's no suspension. And if there's no suspension, load transfers off tires onto other tires very quickly. When load transfers quickly, that means that you have a lot of initial grip. The car is very responsive. When the opposite is true, when the suspension allows the car to roll and pitch, that delays load transfer, and you can say that the car has more overall grip. Now, how do you notice this on the track? I tried to explain it here. So if your handling problem occurs after a peak of traction, so for example, your car catches bumps or flips over entering corners, or enters corners well, but then you lose the rear suddenly mid-corner, or if you hit a bump or dust or sort of change in traction level on the track, you lose all your grip suddenly. If that's your issue, then you have too much initial grip and you need to reduce it, gaining more overall grip. So you need to make your car more easy. Then on the other hand, if your problem occurs because your car's not responding well, you just seem to be sliding smoothly around the track, you don't have good grip at all, maybe your car pushes a lot, you don't have enough steering, maybe you have difficulty accelerating, the rear end doesn't have grip, it fishtails as you try to accelerate, or maybe your car is actually quite easy to drive, but you're just really slow. That means that you don't have enough initial grip. So you need to go for more initial grip and less overall grip. You need to make your car more fast. This explains why it's possible for two drivers to drive the same car and one driver feels that they have a lot of grip and the other driver feels that the car is loose. The driver who feels that there's a lot of grip is driving the car within its limit. They are not pushing too far. So they are using that initial grip and feeling like, okay, the car has good grip, it's responding to everything I'm doing. The driver who feels that the car is loose is pushing the car too far. So they have that initial grip, but the problem with initial grip is after that peak, you lose it quickly. So they are constantly pushing the car past the peak of traction and losing it quickly, which makes it feel like the car is loose. And I can show you this graph. This has to do with tires, but this will make this point clearer. Tires, the way tires produce traction in a corner has something to do with slip angle, as it's called. We don't really need to talk about that in detail. I added a really good YouTube video in the course material, so you can check that out if you want to understand more about the slip angle. But for now, we can just say that imagine the tire is on the track. The part of the tire, the contact patch that's touching the track is stuck to the track, and then you turn the tire. Well, the part that's stuck to the track can't turn because it's stuck there, right? So the tire twists a bit. And then imagine you start rolling the tire like that. Well, the direction that the tire is rolling and the direction of the tread that's stuck on the track, there's an angle difference there. They aren't heading in the exact same direction. The tire is being twisted. That angle is called the slip angle. And the way tires produce a cornering force or grip in a corner is or has to do with this slip angle. At a certain angle, a certain tire will produce the most grip. So if we look at this graph, we can see this blue tire, the amount of friction that it can produce is high. But you have to be very precise. It needs to have a particular slip angle to produce that amount of grip. So this tire will be hard to drive at the limit. The really skilled and talented drivers can do that. They can get the most out of this tire because their skill level is so high, their inputs, their connection to the car, it's so fine-tuned that they can drive it at this limit and they will be really fast. But a less skilled driver will have trouble. They won't push the tire far enough and not have grip. They'll push it too far and lose grip suddenly. They won't feel comfortable driving a tire like this. On the other hand, someone like me, Grandpa Average Joe, I need a grandpa setup. I need an easy car. I'm going to pick a tire like this. The maximum performance is lower, but you can see that the performance is quite stable. It's a wide range of slip angles that produce almost the same grip. So I don't have to be that precise with a tire like this to use it to its full potential. And just to show you an example of this in our world, AKA used to make two different, I don't know, maybe they still do, but they had two different carcass shapes. So this is the Gridiron 2, and it was a smaller tire, straight sidewall, stiffer, small pin. A tire like this is closer to that blue curve. So you have a high peak of traction, but you have to be more precise to really get the most out of a tire like this. Then the I-beam here on the right, this shape of the carcass was a lot rounder. The sidewall is round. It was bigger. The pins are also bigger. So this tire allows for a lot more flex and give, and this is more like that green curve that I showed you. So the maximum traction is lower, but you don't have to be as precise to get the most out of this tire. So this tire will be easier to drive.
I have a question, Joseph.
Yeah.
Do you know if any of the manufacturers in RC actually get down to this level of like slip angle, or are they just, feeling it?
I don't think so. Oh, you mean
No.
tire manufacturer? I don't know.
Yeah.
I don't think so. I don't think so. In real racing, they know they can tell you the angle. I don't think we can. Off road is much harder, but I mean in our on road it could be a thing. Okay, so that's tires, but the thing is that the same applies to cars. That sharp blue curve, think of that as initial grip. The grandpa curve, the green one, the easy to drive one, that's overall grip. And the way to achieve more initial grip or more overall grip, that's what we do with setup. And that has to do with what I already explained, time. If we have fast, immediate load transfer, we have a lot of initial grip. The car is responsive, but it's harder to drive at the limit. If we allow the chassis to move, roll, and pitch, we are delaying load transfer. We have more overall grip, and the car is more forgiving and easier to drive. The maximum available grip is less, but it's easier to drive the car to its potential.
So Joseph, can I ask a question?
Yeah.
It was just a really quickie. I was with a pit buddy of mine on Sunday. He's got a K-Show MP10.
Yeah.
And I had you in my brain when we was looking at his car. It was a bit loose on exit, and just as he was coming out, it looked a bit heavy on the throttle. So I said we need to go a little bit softer geometry, get a bit more roll, get a bit more overall grip. But it actually made it worse on the K-Show. And what he ended up doing, he said, "Oh, it's just got worse." We sort of made sure the springs were okay, roll bars were good. He just dumped in a link down. So in theory, using my head again, stiffer geometry, a sort of higher roll center. He said that cured it for him. And it kind of sort of went against what I was sort of thinking in my head at the time. So I don't know if it's to do with working range or not. I was a bit confused by the way that he went in the end, fixed it.
We'll answer that question at the end. So
Sweet.
Good question.
Thank you.
Yeah. So I said that we adjust the time it takes for load to transfer with the setup. That's what we're doing. When we are adjusting roll bars, springs, damping, anti-squat kick up, roll centers, all of these things, that's what we are doing. We are changing the time it takes for load to transfer. The most important part of setup is what we need to talk about next, and that's roll centers. I think that tires are the most important part of setup because they are what ultimately limit the performance of a car because they are in contact with the track. If you have really bad tires, there's no way you can be as fast as an equally skilled driver that has very good tires. It's just not possible. The second most important thing for setup, I think, is roll centers. You could think of roll centers like the backbone of setup, or since we were talking about cakes earlier with Rob, you could say that roll centers is the ingredients to a cake. If you have the right ingredients, you can bake a very good cake, but you could still mess it up also, right? But if you have the wrong ingredients or bad ingredients, it's almost impossible to bake a good cake. So roll center design is very important. And in RC, it's kind of overlooked, I think. I think that manufacturers should have a well thought out tuning window and then a guide for drivers what to do. Now there's just a bunch of holes on the shock towers and some tuning range on hubs and arms, and people do whatever they want. And that's kind of how you can get lost. So let's look at a few videos here to just figure out what I'm talking about. And now you need to hear the video also, so probably I'm gonna have to bump up the volume. That was a problem yesterday at least. The first thing we do is we draw ground level. Then we draw a line through the pivot points of the lower arm and extend that to infinity. And we do the same thing for the upper link. And those lines intersect. Then we draw a line from the same side's tire contact patch to that intersection point. We find the center line of the car, and the intersection point between the center line of the car and that third line we drew, that's the roll center. Now we repeat this process for the other side of the car. And you can see that they match in this case, because the car is symmetrical. So if you have a stationary car at ride height with symmetrical left to right suspension, all you need to do is draw one side and you find the roll center. The reason we need both sides is because as soon as the car rolls or moves, the roll center will also move because the suspension is no longer symmetrical left to right. So I wanted to show that just so we can understand what the things are that affect the roll center. So the lower arm, the position of the inner arm hinge pin, the outer hinge pin, the upper link, inner and outer attachments. The position of these is what determines roll center placement.
A question, Joseph.
Yeah.
What about if the arms are completely parallel? They never meet, kind of in.
Well, then
How?
at that instant, you say that the roll center is at ground level.
Okay.
Okay, then I have another video here to illustrate how the forces are transmitted through the car. You see, we are approaching my next point. Roll centers affect the way the cornering force from the tire is transmitted through the car. As the car rolls in a corner, the shock, the damping and the spring is what resists the car from rolling. But the geometry of the car also plays a part here. And that's what I want to show here in a video. And now what I'll do is I'll twist the hubs as if the car was in a corner. I can't twist the wheels because they're so flexible. So I'm going to twist the hubs. What do you think will happen when the coin drops?
What's that?
There you go. The jacking force is holding the chassis up. If I reduce tension, the chassis drops. In fact, if I twist both the outside and inside hubs clockwise, like they would be twisting in a corner, and I apply enough force, I can actually lift the chassis. So in case you're wondering how that's possible, how the car lifted up, then this will help to explain that a bit. This is really important, so I want to illustrate it even better. So here you can see me rolling the car. This is what the car would do on the track. And now I remove this screw. And there you see, the outside tire flips into positive camber. Now I remove this screw on the inside. And the inside tire flips into more negative camber. So we can see that the outside link is under tension. The hub is pulling on the link and it's pulling on the chassis. And on the inside, the upper link is being compressed. So the hub is compressing the link, pushing on the chassis. So as you can see, there are forces that are traveling in the upper and lower arms of the car. And this, how much of the force that goes into the link and arms and how much that goes into the shock spring, that's determined by the roll center height. So with a higher roll center, I like to say that there's more geometric roll stiffness. The geometry of the car will resist roll more. As the car wants to roll, you understand that the outside of the car would need to move downwards. But like you saw in this video, the upper link is trying to lift the car up. So it's resisting that roll downwards. The higher the roll center is, the more the geometry resists roll as the car drives around the corner. So if we think back again to what we've been talking about, we've said that if the car can't roll, if we limit roll, load will transfer faster. If load transfers faster, we have more initial grip. So a high roll center will make the car have more initial grip. The car will be more responsive. The opposite case, if we have a low roll center, the geometry of the car won't resist roll as much. So there will be less geometric roll resistance. As you drive in a corner, the geometry won't resist roll as much, and the shock spring has to resist that roll. More of the force will travel through the shock instead of the upper link and lower arm. So this roll center design, how the front roll center is designed, how the rear roll center is designed, this is what dictates to a great deal the basic nature of the car. Then with all the other adjustments of the car, we fine-tune it to suit our style or the track conditions. But the basic nature of the car is dictated by the roll center design. We'll talk a bit more about that at the very end.
I have a question regarding you showed the upper arms, how they were affected, how they were pulled or pushed. Does the same thing apply to the lower arm?
Yeah, so if you watch the entire jacking video, I show it there. But basically, for the lower arm, the outside arm is being compressed. So if you imagine that the tire is here, if your arm is at an angle like this and you compress it, it will go down. If it's perfectly horizontal, nothing happens. If it's that angle, it will go up. That's what's happening to the outside arm. Inside arm would be in extension then. So the same thing happens to the lower arm. But when it comes to roll centers and roll center height, the way that I think about it from a handling perspective is that, do I want the car to feel like it's on the track or in the track? These are terms that we use a lot in off-road. So on the track means that when you drive the car around the track, you feel it sort of visually looks high on the track. And also, if it's too much on the track, you will drive around the track scared of flipping over. So as you're driving, you are driving carefully on tiptoes to not flip over. That's the feeling you have when the car is on the track. Then the opposite, when the car is in the track, you have the feeling that if ever you get in trouble, you just get on power, and it's almost like the car gets sucked down to the ground. So you aren't afraid of flipping over. You just pin it if ever in trouble. Now, why don't you then just run a very low roll center? Well, the thing is that when you have really low roll centers like that, naturally in corners, the car slows down more. So higher roll centers, you have more corner speed, more natural rotation and corner speed. So we want to go fast in racing, right? So we would like higher roll centers. But then there's a limit. We also want the car to feel safe to drive and comfortable. So we want to go to low roll centers. So it's a trade-off. Also, there's another problem with low roll centers, because many, especially grandpa drivers like me, we don't really care that much about the speed anymore. We're just like, I just want my car to be easy to drive and never flip over. Based on what I've said, you might think that, okay, let's just make really low roll centers and we're good to go. We have overall grip and the car is never going to flip over. Unfortunately, it's not that simple. And now we have to introduce the last part of the puzzle, and that is the working range. The working range is what I'd like to call the range within which the performance of the car will be good. If we have very low roll centers and we allow the car to roll a lot and pitch a lot, the tire alignments will begin causing problems. Camber change is something that we need, and when we run very low roll centers, we lose a lot of camber gain. So in a corner, the outside tires would roll heavily into positive camber, and that's not ideal. Also, if we have a car that moves a lot and the roll centers are very low, we lose a lot of response, which we actually need. So Paul, I think, had this question. I'm going to hint at an answer here. If our roll centers are too low, then we don't have enough initial grip to make a change of direction. So if we want to straighten out and accelerate, there's not enough initial grip to stop a slide, square up and accelerate straight. So the car will feel lazy and sort of the rear might start fishtailing and not really stop and grip and go. So as with everything in car setup, you always seem to stumble on something like, oh, this is a good direction to go in, but there's pretty much nothing that you can take to an extreme, because it's always a trade-off, something else. So it's more a case of you have all these different options and you have to decide which one to prioritize a bit more and which ones to sacrifice a bit more. But you never choose one and just go 100% in that direction, because there's always something else that gets worse. And for a car to handle well, you need a bit of everything, right? So there's never a situation where you can just go banzai 100% in one direction, because whatever the thing is that gets worse because of that choice, it will negate those last percentage points that you're gaining. So this is something that you have to keep in mind. But anyway, we're getting slightly off topic here. The working range. We have to keep the car within a certain range for it to work well. And I've shown these pictures before. You can check them out once more. What's the harm? This is a car entering a corner. Everything looks okay. All tires are on the ground. It's within the working range. This car, on the other hand, this car is outside the working range. How can I tell? Well, one tire is completely off the ground. That's not good. If we want maximum performance, if we are on 3 wheels versus 4, 4 would be better, don't you think? Also, this outside rear rim is almost on the track. It's better to have rubber on the track than plastic. I'm pretty sure that's also better if that was the case. So here you can see this car is outside the working range, not working in the best possible way. This is another example accelerating. This car is outside the working range. It has heavily rolled onto the outside rear tire, front tires, inside tire is off the track, outside practically off the track too. So this is a car that's not performing at its best. So clearly, the working range is a thing we need to keep in mind.
Very quickly, Joseph.
Yeah.
Is this another situation where the top drivers can effectively expand the working range of a car by being able to run almost over the limit, whereas the mere mortals are more susceptible to being closer to that limit and not being able to catch a slide or react to the fact that the car's
Yeah.
about to flip?
That's what I was gonna touch on next, but I wouldn't say they can. What was the word you used? Like grow it or
So I said, yeah, expand the
expand it?
working
Yeah.
range. I suppose it's just, I suppose they can use more of the extremities of it.
Yeah.
I suppose would be
I would say that they can't expand it, but what they do is they stay within it. So the example I would use is last year at RCGP we had this RCGP loves RC2 segment, and I'm not sure if they released the videos, but there this was really obvious. So that whole idea was that the top 5 qualifiers in RCGP would drive the bottom 5 qualifiers cars from RC2. So that means that the top guys would drive cars they had never driven before. It was some local racer who qualified in the bottom 5 of RC2. They get paired up and they have to drive their car. So here, if you watch the RC2 driver drive their car, you can see that the car is, going outside the working range at times, and you see like you're losing traction, spinning out, mistakes. Okay, RCGP driver gets the same car. First couple of laps, you see similar things. After that, you stop seeing that because the driver has adjusted and adapted to the car and is driving it within its performance capabilities. So now the car looks like it's handling pretty well now, but it's the same car. The driver is just adapting to it. So with steering and throttle and brake inputs, size, timing, the car is handling well around the track consistently within that working range. So this is really also, in my opinion, a good definition between skill and talent, because skill means that you have a high level of skill. Like if you're skillful, you have a high level of skill at a particular task, but you're familiar with it. You practiced through repetition. You've built your skill. So a top driver can drive their car when it's handling like they want it to handle. They can be really competitive. But where talent comes in is when you have to perform at a high level, driving a car that you're not comfortable with, that you don't have a lot of experience with. Then you have to draw on all your skills and talent, because with talent you can adapt quickly. You don't need that much time to repeat, practice, and then be good. You don't have to build up that new skill to be able to drive a different car. No, you adapt quickly because you have talent. That's key when we are talking about driving a car as fast as possible around the track, because maybe this is a good place to conclude this. So we have concluded that tires is what contact the track. So tires are most important. When we think about car setup, we want to think about what's happening at the tire. We know that if we load a tire more, it will grip the track better and more, but only up to a certain point. So then I showed that graph where I showed that the car is in a corner and the outside tire gets more heavily loaded and inside tire lightly loaded. That axle of the car will have less grip than if both left and right tires were equally loaded. So the more equally loaded tires on an axle are, the more grip they can provide. The more unequally loaded a pair of tires are, the less grip they have. Understanding this, we can then start to adjust the car. We can adjust the front end of the car independently from the rear end, but they are on the same chassis, right? So when we do that, we are changing the balance of the car. When we make adjustments to the car, we are changing the time it takes for load to transfer. So driving in a corner, we can achieve a situation where the front end of the car will have a faster load transfer than the rear. That would mean that you drive into the corner, then the front end begins to push, because now front tires are more unequally loaded, rear tires are more equally loaded. Rear has more grip than the front pushes in the corner. This is what we are doing. The fact that the car is rolling and moving, that doesn't cause load transfer. That delays load transfer. If we want to reduce load transfer, we have to lower the center of gravity or build a wider or longer car. The fact that the chassis is moving is an indication of where load is going to transfer, but it's not the load transfer itself. One other clarification. When we drive around the track, let's say we turn left and then we turn right. Let's say that we turn left for exactly half a second, right? Then we turn right. If we adjust the car so that we delay load transfer, we make it softer, we allow the car to roll, for that half a second, less load will transfer because the time is set. We only have half a second in that section of the track. So we reduced load transfer in that section. That's true. But if we gave the car enough time, the same amount of load would still transfer, right? That's my point. So even though we can't limit load transfer in this way by delaying it, practically on the track, that's what we're doing. Because we are racing around the track and we are turning in different directions and we are only giving the car a set amount of time to do something. So when we delay it for that section, in that section, less load transfers. That's just an important point. When we make these adjustments, a good way to think about them is through initial grip versus overall grip. So initial grip means a responsive car, a higher peak of traction, but it's harder to control. Overall grip means less responsive car, more calm and easier to drive, but the peak of traction is lower. The roll centers is the backbone of a car. The roll centers determine the basic nature of the car, and we adjust everything else around that. In tomorrow's and Friday's meetings, we are going to go over the first real settings of a car and not really go through in detail what the effects are, more so just talk about practicing and testing and what we are changing, because the whole point is that we will all go to the track over the next weeks and we'll all do these changes to our car. We'll all keep notes. And then when we have our next meetings, we'll go over the notes and analyze them together. So then the idea is that then we will learn to understand what's happening with the car. And we'll always refer back to these points that we've covered today. So the first part of the homework are sort of really basic ride height, droop, camber, toe kind of things. Just the basic alignments of the car. But then the second batch of homework, which it will go through on Friday, they all have to do with this. So all of those changes have to do with initial grip versus overall grip. And when we do that, I think all of this will become far more clear. So did someone had a question, I think?
Yeah, I had a question. I was thinking of when you said, you know, driving through some parts of a track where when you have it loose so that the load transfer is delayed, so you as you said, you turn left and right, so it doesn't complete the whole load transfer. What do you lose in that sense? Is it that kind of directness, or
Yeah, so
what is it that we're losing when we're not completing the load transfer there?
Initial grip is what brings that peak of traction or responsiveness. So that's basically what we lose.
Yeah, the responsiveness. Okay.
Yeah.
Yeah.
Point number 1, tires. When tires are equally loaded to the right amount, they perform at their best. When left and right tires of an axle are equally loaded, they have the highest grip potential. As soon as you load one side of the car more than the other, the car will have less grip potential. Load transfer is inevitable. The movement of the car doesn't cause load transfer. The movement of the car, roll and pitch, delays load transfer. And that's actually what we are doing when we adjust the car. We are adjusting the time it takes for load to transfer, which means that in a given section of the track, because time is limited, you turn left, and after half a second, you turn right. So in that left-hander, you have half a second to transfer load. If you slow that down, less load will transfer in that left-hand corner, right? So if you give enough time, the same amount of load would still transfer. What we are doing with setup is changing the speed at which this happens. And when we adjust the front and rear differently, we adjust the balance of the car. And that's where it becomes difficult, because front and rear need to be set up in a way where the car feels comfortable to drive. If front and rear are off balance, we will have handling issues. And it all comes down to the time it takes for load to transfer in the car. When load transfers quickly, we have more initial grip. So the car is more responsive. The first change that happens as you turn into a corner, you have more grip. When load transfers slower, so we delay it, we allow the car to roll more, you have less initial grip and more overall grip. And finally, the roll center is the backbone of the car. It determines the nature, the characteristics of the car. And all the other adjustments we make are minor adjustments to tune the car to the track conditions or to driver preference. And when we drive the car around the track, we have to remember that there's a certain working range that the car needs to remain within. Higher skilled drivers can have a car that's harder to keep in that range. A car like that will have a higher maximum performance capability, but it's harder to achieve. Grandpa setups mean that the car is easier to drive. It's easier to keep it within that working range. Your inputs can be slightly sloppy, timing can be a bit off, size of steering or throttle inputs, they can vary lap to lap. But if you look at the car, it looks calm and stable and good.
Do you
see on the track that a car has low roll centers or high roll centers? Can you identify it by seeing or by driving it? You personally?
Yes, you can. So I don't think I have the picture here now, but if you look at the jacking video, there's a part of the video where a car with a high roll center drives around the corner, and a car with a low roll center drives around the same corner. And then I captured them in the same position in the corner, and you can see clearly that the one car is high up and the other one is arms level. So visually, you can look at the car on the track and make a judgment of where the roll center is just by how it's handling in the corners. Is it rolling downwards, or is it staying level, or is it lifting up in corners? That's one way. And when you drive it yourself, when you have low roll centers, you have this sense of the car being in the track. So whenever you are in trouble, if you get on power, it's like the car gets sucked down to the track. And then with a high roll center, you drive around the track and you have this feeling of being scared of flipping over. And then if we take this one step further, front, I can show you, front and rear roll centers are connected. If you look at the car from the side, you have a front roll center somewhere and a rear roll center. And if you draw a line here through the roll centers, you have a roll axis. The roll axis is what determines the nature of a car. I would say sort of mainly entering and exiting corners. That's where you notice it the most. Okay, so if you have a car where the front roll center is lower than the rear roll center, the car will have good steering and rotation, and in my opinion, it's the way to go. The question is how much you want to angle it this way. So turning into the corner, let's do this. Let's analyze this from the perspective of what we just discussed. Okay. So you enter the corner and the front roll center is low. That means that the front geometry is softer. It allows the car to roll. So you have less initial grip on the front. So that the front won't be so aggressive into the corner. On the rear, you have a higher roll center, so higher stiffness. So as the car enters the corner, you have good initial grip on the rear. So on corner entry, the rear will have good grip. So you are quite neutral entering the corner. Then as you get in the corner, the front and rear, the front, left and right tires are more equally loaded at this point. You have good grip mid-corner. So the front wants to turn the car. Now on the rear, you have the higher roll center, more geometric roll stiffness, which means that mid-corner, now the outside tire is heavily loaded, inside less, which means you have less rear grip in the corner, which means that the rear allows the car to turn. It's not gripping too much. So in an extreme case, if you angle this very much, you go in good, and then mid-corner the rear wants to slide. Right? Well, let's say you haven't angled it too much, so you went in smooth, then mid-corner the front has good grip, turning the car, the rear loses a bit of grip, allowing the car to rotate. Then you get on power. When you get on power, you want the rear to grip. You want the car to accelerate straight. With a high rear roll center, you get on power. Load transfers quickly. Again, you have good initial grip, right? you are straightening out. You want the response of the rear end to be quick, the load to transfer quickly. And that's exactly what a high rear roll center does. So in this situation, I think that having the roll axis this way is beneficial. If we think of it the opposite way, so the front roll center would be high and the rear roll center would be low. This is what, for example, plagued the HB back in the day. Maybe now less, but if you watched a lot of sort of hobby drivers, they would have a car that they accelerate and the rear is fishtailing a lot. Well, we can explain it through this also. So high front roll center, high geometric roll resistance. The car is quite responsive. The front end bites quickly, turns the car into the corner. The rear, low roll center, so softer. As the front bites into the corner, the rear doesn't have a lot of initial grip. But then mid-corner, as you get into the corner, the rear tires are still more evenly loaded. So mid-corner, the rear has good traction. So you go in aggressive, the rear doesn't respond that much. Mid-corner, the rear grips well. You get on power, the front responds quickly with a high roll center. But the rear doesn't have enough initial grip to stop a slide or straighten out. So when you get on power and accelerate, the rear is wanting to fishtail. So basically what I'm saying is the direction you angle this roll axis will determine the basic nature of the car, how it enters a corner, how the grip is distributed in the corner, the nature of the car when you accelerate out. And what you then do with all the other settings is make up for this. So different cars can require different settings to make them handle how you want.
Joseph, will changing roll center at the hub affect anything else? Camber, droop? I think it'll affect droop, yeah?
Yeah, well, droop is something that you should always check separately. And this is why like shock length isn't a good way to measure droop. The actual physical droop is what matters. And that's what you should measure, in my opinion. Changing the axle height will change the shock length for the same physical droop. Camber change is very difficult to quantify because always when you change roll centers, you're also changing camber gain. So you can't separate the two completely. They always go hand in hand. So the way I think about it is roll centers affect the jacking, so in the track or on the track. And roll centers affect initial versus overall grip. But then camber change affects the sort of maximum available grip. Because if you want to understand how important camber is, just go to the track and the only thing you change is camber. And there you can see how big of a difference it is. Not on all cars, but for example, the Mayako camber is a really big deal. And even our top drivers, they don't appreciate how big it is. So that's one reason why they're going to have to do the homework. Because I think one of the first parts of the homework is camber.
So, okay, when we're driving, right, and we are just say we're going out, say we on the track, we just learning the track, and we filling out like where the grip level is, like for the car. Like we don't want to go over that, because when we go over that, that's when we start, like fishtailing and kind of overdriving the car. So My question is, when we go up to that point where we see like I guess the farthest we can push the car until we get to that point where it loses traction or whatever. At that time, when we get to that point but not over it, is that the time that we would should focus on, like the time that we should adjust the car in that point, in between that point of we finding out the limits of the car? You understand what I'm saying? Is that where we should then say, okay, well, the car is still pushing, but I know I'm not pushing it. I'm not basically overdriving the car. You know what I'm saying? So
Yeah, so I think, I don't know if it was in this meeting or the other one, but it was yesterday, I believe. I was talking about how the connection to the car is key. You have to have a connection to your car. You have to be able to drive consistent laps, and you have to have a feeling of what the car is doing. You have to be able to do almost identical laps, and you have a sense of, now I pushed a bit more in this corner and I'm losing the rear end mid corner, right? And then the next lap, it doesn't happen because you're a bit more careful in that section. So now, through repetition, through consistency, you have identified a limit of performance. This particular corner, when you drive in this way, everything's fine. You go just a bit faster and you lose the rear end. You slow down a bit, now it's good again. So at that point, you can say that you have identified a limit, a limiting factor in that corner. That's when you can make a change to the car and actually notice a difference, because then you can drive the same way again after your change and note, hey, I don't have that problem anymore. So unless you have this connection with your car, unless you can notice these kind of things, making changes is, I wouldn't say pointless, but it's close to it, because you won't really know what the changes are doing. So you have to be in tune enough to understand how you're driving the car, what's happening to the car, and then when you make a change, you can notice the difference. That's also a way to improve your driving when you notice something like that, because maybe it's a section where you can drive better or improve your driving. So I don't know if that answered your question, but
yeah, it's putting you in a position where you can see where, okay, I'm up to this point. I know to push this car to this speed, but if I go over this speed, then it's gonna lose traction. So you give yourself a area where you'll know, okay, I can't push it past this point. Now I can go back and maybe I can change this that may let me push it that little bit more that I need to maybe, to keep the pace or whatever. You know what I'm saying? So
yeah.
I have a question maybe for Jared, but you can answer it as well, Joseph. I know yesterday we were talking about when tuning the shocks that usually you start with a thinner oils and you go thicker, and I guess for a user, in this case you're also starting with maybe a car that rolls more and then kind of stiffen up to be more responsive. How often do you change that? And starting directing this to Jared, I mean, how much do you adjust your upper arms and kind of the geometry of the car, or is it more the suspension and the shocks that you play around with and tires? Or
For me, I wouldn't say I adjust my the inner link on the upper, on the upper camber link or upper arm, if however you want to say that.
Yep.
I don't adjust that a lot, but I will when it's like an extreme grip level. And, one thing that I have found trying to say like, oh, this setting rolls more or rolls less, I think is really difficult. For me, I think of it more as like pressure, like what does it do as far as like pressure on the tires? And so that depends on the grip. Like if it's a low grip kind of condition and I want a lot of pressure quickly on the tires, then I will lower the inner link or possibly raise the outer link. And, that's going to generate more grip initially on, like a lower grip situation. And then say for like the opposite on a high grip situation, if my car is edgy, feeling like wanting to flip over and go like up on two wheels easily, then I'll raise the inner link. And to me, it's like that puts less pressure on the tire and kind of like that less initial grip, like Joseph was saying. And that will smooth it out. That's not something that I'm gonna do first, like a first thing on my setup, changing. I would say I more so kind of mess with like my links of the camber links a little bit more first. Not sure how that answered your question.
Yeah, it did. How about you, Joseph? How do you approach that?
We can go through this because someone asked something similar to this in the first meeting today. I'll show this picture. It will be easier to explain. This is how I think about the setup. So we know that all these locations affect the roll center, yes, but the arm is a very powerful tuning aid because of the force that travels through it. Not just because it changes the roll center. So if I'm at a different track, the first thing out of these things that I would touch would be the lower arm position on the inside. And just a 0.5 mil change here is already a noticeable change. So this is a very sensitive change to make. If you lower the arm here, the car will be softer in roll. If you raise it, car will be stiffer in roll. And that's what I think about. So rear end support is something we have discussed. If I feel that I need more support.
Could I jump in real quick and ask you something there, Joseph?
Okay.
Like right there, you say softer in roll, stiffer in roll.
Mm-hmm.
And I feel like that is a poor term as far as our cars, because most people, like if you're at a track and you're like, well, my car is loose, and you say, okay, well, this is going to soften the roll, a softer roll. Most people are going to think that's going to generate grip. But if you lower your arm, you're going to have less pressure on the tires and your car is going to generate less grip. So that's why I was kind of saying, like, I have a hard time thinking about it as more or less roll. Because when you say, because I would agree there, moving those arms is that kind of sets your like general grip of the car.
This is why it's.
But wouldn't it use?
Go on.
Go ahead.
Oh, you finish what you were saying.
I was just gonna say, lowering that down, that's less pressure being put onto the tires. I feel like when I'm driving, like if I'm at a loose track and I lower my arm down, I feel like it's forcing my tires into the track less, and the car is generating less traction. If I raise my arm up, the feeling that I have is that it feels like it's forcing the tires into the dirt more and generating more traction. So on a loose condition, I like my arms raised up. But then you fight something when the traction comes up. Sometimes your car wants to flip over because of that load that it's putting on the tires. When the car is squatting, it's putting more pressure on the tires, causing it to want to flip over.
Yeah. This is why it's important to talk about initial grip versus overall grip and not just more or less grip. Because a better driver can raise this position and feel like they have more grip. Most drivers won't, because you have more initial grip. So if you push it beyond that, then your rear will break loose suddenly. So you have more initial grip, you have a higher peak of traction, but you also lose that faster. So if that's your problem, then lowering the arm would actually be better, because you have more overall traction at that point. But when I adjust this, I don't adjust it for traction, really. I don't really think about grip when I'm doing this. I'm thinking about support, because this affects rear end support so much. So if you lower this point, you have less rear end support. So as you accelerate, the rear will squat more onto the outside tire as you're exiting a corner. If you raise this position, the rear will stay more flat and it won't squat as much. So when I adjust this, that's what I'm doing. And it has to do with the traction level of the track, the speed of the track, if it's the layout of the track. If there's a lot of like high speed corners where you're really pushing the car, you can get in trouble if the car squats too far. Working range, remember, you want to keep the car within the working range. So it could be hard to drive because the arm is low, allowing the car to squat too far in some sections. So then it can be easier to raise the arm a bit, gain some support, keep the car within the working range. You're good to go. So this is the first area that I would think about changing on a track. And like I said, I think about this in terms of support. Either I need more or less. That's what I do with the height of the arm. I would say that the second thing would be the length of the link on the hub, front and rear. I tend to match front and rear to not have a big difference in the lengths of the links. What this does is I purely think about the length of the link as, do I want things to happen quickly or slowly? A short link, things happen more quickly, there's more response. A long link, everything is smoother and more calm. So again, initial versus overall grip. Short link for initial grip, long link for overall grip. So that's one is the lower arm height for support. Two is the upper link length for fast or slow responsiveness. Then I think axle height. So normally I run the same axle height everywhere. But if I was to change it, if I lower the axle height, I will have a more initial grip. So the car squares up quicker, accelerates faster because of that. I have more side bites, so it's worse in bumps. But if I have the problem that my car just feels loose, let's say the rear end of the car just feels loose everywhere, I could lower the axle height to get more grip. If I have the problem that I'm catching bumps in corners, my car feels edgy, the rear end feels stuck, I could raise the axle height, have less side bite, free it up in corners a bit, have it not catch bumps. Front is basically the same idea. I need more responsive steering. I can lower the knuckle. The front end is catching bumps in corners. I raise the knuckle. And then I would say last of all would be the link on the tower. And that's exactly how Jared explained also. High grip track, I would move the link up to lower the roll center to have the car more in the track. So with the link, I really think about in or on the track. The sort of roll center height thinking of in or on the track, that's what I do with the link on the tower. And then finally, you are also able to adjust the entire height of the link. So you could lower the link on the inside and the outside and keep the same angle. Or that has a minimal change on the roll center. So I don't think of that as in the track or on the track. what that affects is initial versus overall grip, I can say. So the higher the link is, the less effective this link is at pulling or pushing on the chassis. So that means that it doesn't resist roll as much. It's more forgiving. A higher link is more forgiving for the same roll center height. So if I'm on a track and the track has bumps, edgy, I want to make the car as easy to drive as possible, I would have the link as high as possible. That's why I always start with the link as high as possible. And then if I want more initial grip, I lower that entire link. By lowering that entire rear link, for example, going into a corner, you have good initial grip, the rear grips well, but then mid-corner, the low link allows the rear to break loose a bit to help the car rotate around the corner. Then when you get on power, the rear locks up again because of initial grip and stops sliding and accelerates straight. So yeah, that's my best explanation of that.
And when you adjust the length of the upper link, do you move the outside holes or the inside? I guess that also matters.
Outside, I would say.
Okay.
Yeah.
Joseph, are you using, I mean, there's obviously some of these adjustments, like say you change the hinge pins on the lower arms and then you change the camber link on the inside, they can obviously negate each other to a certain extent. So if you use the hinge pins for support and then you change the upper camber link, you can then actually get more in the track feel, which is obviously sucking the car down. How do you balance it? Do you just use the biggest adjustment first? Is the other just a fine tune then, like the camber link?
Well, that's why I say that car setup is an art and not an exact science.
Yeah, I get it.
The way I would do it is, like I said, for the lower arm, I think about it as support, and then in or on the track, I adjust it with the upper link. So it's like you said, if you run the lower arm higher and then you also raise the upper link, you can have a car that is clearly in the track, yet it still has support from the lower arm, so it's not too soft and collapsing on the rear end when you accelerate.
In theory, is it possible to have a situation where you can, just purely from a geometrical point of view, you can actually have exactly the same roll center height by moving both the upper and the lower arms, so you end up with that intersection point just further outboard or further inboard,
Yeah,
but have exactly the same roll center height?
you can
What would your the effect be of having that? Would that just be the change in support that you gain, but have the same in on track feel?
you can have the same static roll center height, but as soon as the suspension moves, the roll center moves also, and that's not going to be the same anymore. So
I get you. So it's changing the roll center migration left to right,
so
effectively by changing that swing arm length.
exactly. So it changes the like geometric roll resistance and also camber change. So it won't be the same. Like even if at that one moment with the car set to ride height, the roll center could be in the same position, but handling won't be the same. Baz says, is that the same as the laws of physics don't apply on Astro? Nothing applies on Astro. Astro should be banned for RC. Carpet and Astro, ban that. Unless you're running a touring car. Oh, Tebow had to leave, damn it. And I was going to show him a graph. Let's show the Tebow graph.
Yeah, show us the graph.
It's too bad that he left, but I was looking forward to this.
One thing I thought on that very quickly while you're talking about Tebow, and he's not here. So could you think of, you know, your tire graph that you put up of the theoretical tire and F1 tire, road tire? Could you think of the peak of coefficient as a pressure curve almost? So as Jared was saying, he feels that initial grip, as you were saying, is more a pressure on the tire, and then the overall grip is actually what he's feeling is initial grip, not overall. And because the peak is higher, he's able to use that peak, whereas the rest of us effectively can't, because we're not good enough to keep it within that smaller area above under the curb. Sorry.
Yeah, but that initial grip is that load transfer loading the tire more, providing a peak of traction. That is what it is. Like it is actually loading the tire more. But
yeah, that's right. I did understand what you were saying, and that's right.
Yeah. So that, yes, that is ultimately faster, but you have to be a better driver to be able to manipulate the car in ways where you are moving the load to the tires you want to have load. Like, let's say you're turning into a corner. If you brake and then turn right as load is transferring onto the front axle, those front tires will have more grip. Load is transferring off the rear tires, rear end will have less grip, right? So it would be easy to oversteer in that position. Maybe the rear would slide out and you'll spin out. You'll lose time. If you are in tune with your car and your inputs, you do the same thing. You get the car to turn, but you correct. You don't turn the wheel too much. You turn just the right amount to initiate the steering. And as you have let off the brake, you get on the throttle early enough. You balance out the car as you're going around the corner. You got the steering initially because load was on the front tires. And car turned in aggressively. When you balanced out the car in the corner, you are cornering at, a steady pace. You have good grip in the corner. You begin to accelerate. You get on throttle. Load transfers onto the rear tires. You start straightening out the front tires. All your inputs are timed perfectly. You have a very responsive car. The grip is high because the load is transferring quickly onto some tires, off others. You see, like if you have the skill to do that, it can be very fast. But Grandpa here would have spun out and would be being marshaled right now. That's the problem. That's why overall grip is easier.
Describing how I go into corners.
There you go. So you need to head on over to the green column. Easy. Anyway, let's look at this graph. This was gonna.
I would be interested at
What?
How far, even though Mr. Table left already, but how far he is in the initial grip scale. So compared to some other drivers, drivers.
This we have to deal with another day.
Yeah, okay.
But here's another point of confusion. You see, low grip, high grip, roll bar thickness. This is another problem we have. We tend to think of adjustments as, oh, I head in this direction and this happens. So it's always going to be better up to a point. Well, this can also happen. So low grip track over here, high grip over here. As the grip of the track increases, what we do is we go to a thicker roll bar. But we only do so up to a point, because after a certain point of grip on the track, a thinner roll bar is actually preferred once again. So this kind of situation will cause confusion also when it comes to setup. When someone asks, I'm going to a high grip track, should I put a thicker roll bar on? Well, yes and no. See, the problem for me right now in giving advice to people is that years ago, it was a lot easier because I knew less. So it would easy to give advice. Someone asked me, I'd give them an answer. Now I don't know what to say anymore. It's like I have to do a full analysis of everything. Like, okay, so what setup are you running now, and what car are you driving, and what's your skill level, what's the track like? I have to know so much more to be able to give an answer that I'm actually happy with confident this is going to help you. So,
yeah. Can you explain this particular curve? Why with the roll bar here? Why this is?
Okay, so I would say that it's because as grip increases, you want to go to a thicker roll bar initially to keep the car within the working range. You don't want to have it move around too much. You want to limit roll. You want to keep that same balance. Okay, so you go up on the roll bar. But then there comes a point in grip where the car can't really slide anymore. Or maybe it can, but that point is so far from where you are that essentially the cars don't slide anymore. And I think at that point, things start changing, because the problem with going to a thicker roll bar is initial grip, right? The car is responsive. But you don't want that when the grip is super high on an off-road car, because you want to allow the car to roll and be more forgiving. Let's say you have a small roller, and in that section you hit it just a bit wrong and the tire catches, the front tire lands and catches afterward. With a thick roll bar, the car would just suddenly flip over. You don't want that. You want it to be a bit more forgiving so you have time to respond to these kind of things, right? So going to a thinner bar would allow the car to absorb those kind of situations. So then instead of limiting the movement with roll bar, what you would do is you go to really thick damping instead. You make the shocks thick, and you slow down the roll so much with the shocks that in those sections of the track, the car doesn't have time to roll far enough. So
it's something I'm going to try next time, actually.
Yeah. This is actually...
I noticed that with a lot of Mugen drivers do that. I mean, our track is like a oil track, and they're running like 65, 70 weight oils. Like, you know, Clancy will be running 65, 70 weight oils in his car.
This is something I'd like to see the Astro boys try, actually.
It's exactly where I'm going to try it. I have an Astro track where I traction roll a lot, and I'll just go up on the roll bar, and it's not doing what I wanted it to do. So I'm going to try this.
Yeah, I would like the Astro boys to try really thick shock oil and like big holes in the piston. So maybe less holes, but really big, and then really thick oil. Like it's actually on the table, it feels super thick, and then quite hard springs, but then thin roll bars. That so the
bigger holes than 6 or
what?
Even bigger? Bigger holes than 1.6?
5 1.6?
Yeah, for example.
Yeah, I think UK Nemo round, I think we ran 517, 518, I think. Or was it 516, 517? But anyway, bigger than normal, and like diff oil in the shocks. So the whole point was that you have really thick oil to slow down the damping, but then big enough holes to not have too much pack. So the pack was still okay, but the damping was really heavy. And then we ran thinner roll bars like that.
Yeah, I've actually gone down with the roll bar and up with the oil. I'm running 800, 750 with 5 1.6, and that feels much better than running a thicker bar.
But then again, like this, what we're talking about now, it's not like that's the only way. Because, for example, the Kilich brothers, who drive all crazy, if you've ever seen them drive, they run like 3 mil roll bars, so 3.2, and so they don't follow this way of thinking, right? And again, that's what I say, that setup is an art form, not an exact science, and the driver plays a big role in that decision, which way to go, because the driver is who needs to be comfortable with the car. I think most people wouldn't be comfortable with how the Kilich brothers run their cars, but they are, and that's what matters at the end of the day.
Wouldn't you lose your low speed responsiveness by going that thick on the oils, like in tight corners and stuff?
Well, a bit, but you can. The hard damping also gives you some initial grip, you know, because while the car does roll, the damping is so hard that if you just like turn into a corner, it doesn't really roll that much. You get enough initial grip to turn. But when there's when there's more force applied, instead of a hard roll bar limiting the roll, then the damping gives way. So you do still have enough response, and also there's other ways of getting response if you want it. Like you can run less kick up, for example, stiffen up the front suspension in that way. Other ways of achieving, or changing your front toe or Ackerman, those kind of things.
Okay, so when you do that, it's more like a series of changes that are gonna get you to where you need to be.
Yeah, exactly. So yeah, anyway, that graph, I was just thinking that that's sort of another area where you could have two different opinions of something, even though the underlying physics of it is not somehow magical. It's the same. It's just the requirements and preferences are different.
So Joseph, at Nemo, oh, sorry, did you end up running fairly standard roll bars at Nemo then? Just with this heavy diff, the shock oils? Yes, we did. I think the setup sheet's on the website. Okay. But pretty standard. I don't know if Robert is here, but I remember he said he was so surprised at the Euros, last year Euros, because David ran like a 2.2 or 2.1 or 2.2 roll bar in the front, I think. 2.2 front, 2.6 rear. And like most drivers were running like 2.5, 2.6, like really heavy roll bars, and rear probably 2.8, each on 3 and 3.2. So it was so different to what most drivers were running, but this was the reason. Roll bar was thin, but damping was hard.
A lot of us at Nemo as well. Sorry, just carrying on what Paul was saying. A lot of us at Nemo last year, we left the shocks and the roll bars where they were for a standard dirt setup, and just went higher on diffs, and massively higher. Is that effectively doing something similar, but you're taking the grip away, that initial grip away, by locking the diffs and not letting them run as freely, or is that a different meeting?
That's a different meeting, but yes, I think that with the diffs, when you have really heavy diffs, it just makes the transition from on power to off power that much smoother. So off power, the car is so much stable because the diffs are resisting steering. They're not allowing the car to change direction.
So again, slowing everything down rather than taking away the initial grip by slowing things down from the diffs rather than slowing things down from the suspension itself.
Yeah, for like Nemo conditions, yes, I would say so. Nemo, for those who don't know, is a carpet track.
Crazy high grip.
Yeah.
Next to no jumps. Really flat.
Ridiculous. Okay.
Good for running engines in.
What?
It was good for running engines in.
Oh, okay. So anyway, that's all I had for today. These things, as I said, when we go through the homework, especially Friday's homework, we will refer back to this that we've discussed today. And when you get the hang of this way of thinking, I think that setting up your car will become easier. You can start making your own decisions, and you can also figure things out, because I don't want you to have to memorize stuff. I want you to understand, and when you understand, it's different. You can look at things, think about them, analyze them, and make up your mind instead of trying to memorize something like, oh, what's the effect of this? I think that's a better situation when you understand. Okay. Any more questions, or we good?
I just wanted to make a quick comment that after watching your anti-roll bar video, I was having an issue, and you're going to hate this because this is on carpet, but two-wheel drive carpet, coming out of a straight, going into a sweeper and then to a roller, I would enter that corner a little too fast sometimes, and this is that would happen around the track too, where my inner rear tire would come up off the track, and I thought I had to add, you know, maybe a higher or stiffer roll bar, but after watching that video you put out, I lowered the roll bar weight a little bit, and that fixed that problem completely.
Yep, that's right. So again, it's because when you stiffen the suspension with an anti-roll bar or high roll center, you aren't allowing the car to roll. So if the car can't roll, especially on carpet, because it can't slide also, then it's going to lift up. That's what happened there. And I'm glad the video helped you. I had someone in the comments disagreeing violently with me. That was fun. I think it was that video. Okay. We continue tomorrow. Tomorrow we go over the first homework. So, see you then.
Thank
All right,
you.
thanks, Joe.
Tomorrow. Thanks for tonight.
Yeah. Thank you.
Bye bye.
Cheers.
Bye bye.
Great session.
Thank you.